The next part of this is if I give you the parts and pieces, can you make the equation? And so on this one, it says our vertex is at 3, 2. So the first thing you want to do is to get a picture of this. So that's your vertex. We have no idea which direction it opens, but if the focus is at 1, 2, and we know that the focus always has to be inside the parabola, that means it's going to have to open to the left. So it's going to have to be a y-squared equation. Then we can count the distance, which is p, that's 2. And since we're opening to the left, that means p equals -2. And so if we start from the top, we will have y minus 2 squared equals 4p x minus 3. That's just putting in the h and k for the vertex. Now that we know that p is -2, we can say y minus 2 squared equals -8 times x minus 3. That would be the equation that would give you that parabola. Another version of this is example 11 here. So if the focus is at 2, open to the right, because the directrix is kind of like an asymptote, it never crosses it. So if it's going to open to the right, that means it's a y-squared. Your vertex is always the midpoint between your directrix and your focus. So in this case, our vertex must be at 0, 2. And so now that we know that, we can count the p-value, which is going to be 2. So putting it all together, what we know, our parabola is going to open to the right. And so if we put in our vertex, that would be y plus 2 squared. Actually, it's going to be y minus 2 because it is opposite in here. So it'll be y minus 2 squared, and then equals 4p x minus 0. And so if we put in our p-value, that's going to be 8, and if you just want to simplify that to x, you can. So this would be the equation that comes from all of those parts and pieces.